Right now, as you're watching this video, somewhere in the universe, two monsters are dancing. Not dancing like you and I would dance, but dancing in a cosmic ballet that would make every nuclear bomb ever created look like a firecracker. These monsters are black holes, each one containing the mass of millions of suns, and they're spiraling toward each other at speeds that would make light itself jealous. And here's what will absolutely blow your mind when they finally embrace. They don't destroy each other. They become something even more terrifying and beautiful than either could ever be alone. What if I told you that the very space you're sitting in right now, the empty air around you, is still rippling from black hole collisions that happened billions of years ago? That your body, this room, this entire planet is being gently stretched and squeezed by waves in space-time itself, created when cosmic titans merged in the darkness of deep space? You can't feel it, but it's happening. Right now, but here's where it gets really wild. What if I told you that we've not only detected these mergers, but we've heard them? That's right, we've listened to the universe's most violent events like they were songs. And the most shocking part? The first time we heard it, it changed everything we thought we knew about reality itself. Before I reveal how we discovered that black holes can merge, and why this discovery means you're connected to the most powerful events in the universe, hit that subscribe button and let me know in the comments. What country are you watching from? And what time is it where you are? I want to know how far across our planet this cosmic story is reaching. Because what you're about to learn isn't just about black holes merging. It's about how you, yes you, are made of the ripples they create. Now, let's start with what seems like a simple question, but the answer will completely change how you see reality. To understand if black holes can merge, we first need to understand what a black hole actually is. And I guarantee you, it's not what you think. Picture this. You're holding a bowling ball, and you want to compress it down to the size of a grain of sand. Not just squish it, but actually compress all that matter, all those atoms, into a space smaller than you can see without a microscope. The gravity from that tiny grain would be so intense that if you dropped it, it wouldn't just fall through the floor, it would fall through the entire Earth, pulling everything toward its microscopic center. That's essentially what a black hole is, except we're talking about compressing not a bowling ball, but entire stars, sometimes millions of them, into a region smaller than a city. Think of it like this. Imagine space-time as a stretched rubber sheet. Now place a marble on it. The marble creates a small dip, right? That's how our sun curves space-time. Now imagine taking a cannonball and placing it on that same sheet. The dip becomes much deeper. That's a black hole. It curves space-time so severely that it creates what's essentially a hole in the fabric of reality itself. And here's the mind-bending part. Once something falls into that hole, it can never climb back out, not even light. That's why we call them black holes. But here's what most people get wrong about black holes. They're not cosmic vacuum cleaners, sucking up everything around them. They're more like cosmic lighthouses that have gone dark. If our sun suddenly became a black hole right now, don't worry, it can't actually happen. We wouldn't get sucked in. We'd keep orbiting at exactly the same distance, just in the dark and very, very cold. The gravitational pull would be identical because the mass is the same. Now, here's where it gets really interesting. Black holes aren't just single objects, floating alone in space. They can exist in pairs, orbiting each other like a deadly cosmic dance. These are called binary black holes, and they're more common than we ever imagined. Picture two massive whirlpools in the ocean, each one spinning independently, but slowly getting closer and closer to each other. As they approach, the water between them gets more and more chaotic, waves crashing and interfering with each other in increasingly violent patterns. But with black holes, those waves aren't water. They're waves in space-time itself. And this is where Albert Einstein comes into our story in a way that even he didn't fully understand. In 1915, Einstein published his theory of general relativity, which told us that massive objects don't just sit in space, they orbit. Space and time aren't separate things. They're woven together into what we call space-time, and massive objects create curves and dips in this fabric. Einstein's equations predicted something remarkable, that accelerating masses should create ripples in space-time that travel outward at the speed of light, like ripples on a pond when you throw a stone. Einstein called these gravitational waves, but here's the shocking part. He didn't think we'd ever be able to detect them. He calculated that they would be so incredibly weak by the time they reached Earth that measuring them would be impossible. He was almost right. Almost. What Einstein couldn't have known is that the universe contains events so violent, so energetic, that they create gravitational waves strong enough for us to detect. And the most powerful sources of these waves? Black holes merging together. But wait, if black holes are regions where nothing can escape, how can they merge at all? Wouldn't they just orbit each other forever? Here's what will blow your mind. They do orbit each other for millions or even billions of years, getting closer and closer in an ever-tightening spiral. And the reason they spiral inward is because they're literally losing energy by creating those gravitational waves. Einstein predicted. Think of it like this. Imagine two ice skaters holding hands and spinning around each other. If they could somehow lose energy while spinning, they would slowly spiral inward until they crashed into each other. That's exactly what happens with binary black holes, except instead of losing energy to friction or air resistance, they're losing energy by creating waves in space-time itself. As they get closer, something extraordinary happens. The gravitational waves get stronger and more frequent, like a cosmic heartbeat speeding up. For millions of years, these waves pulse out maybe once per minute, then once per second, then faster and faster. In the final moments before merger, they're pulsing hundreds of times per second. And here's the most mind-bending part. In those final moments, the two black holes are orbiting each other at nearly half the speed of light. Half the speed of light. We're talking about objects that contain the mass of dozens of suns, spinning around each other 30 times per second at speeds that would make a photon of light sweat. The amount of energy being released in those final seconds is more than all the stars in the observable universe combined. But here's what really gets me, and this is going to sound impossible until I explain it. When two black holes finally merge, the resulting black hole weighs less than the two original ones. Combined, where does that missing mass go? It gets converted entirely into gravitational wave energy and blasted out into the universe at the speed of light. We're talking about the equivalent of 3 or 4 entire suns worth of mass energy being released in a fraction of a second. Let me put this in perspective for you. The atomic bomb dropped on Hiroshima converted about 0.7 grams of matter into energy. That tiny amount of mass energy destroyed an entire city. When two black holes merge, they convert the equivalent of several suns. That's roughly 4 trillion kilograms into pure energy in less time than it takes you to blink. If you could somehow harness that energy, you could power every device on Earth for longer than the universe has existed. But here's the beautiful part. That energy doesn't just disappear into space. It travels outward as gravitational waves. And those waves carry information about the collision. They tell us the masses of the original black holes, how fast they were spinning, and even the mass and spin of the final merged black hole. It's like cosmic archaeology. We can reconstruct the entire collision just by analyzing the waves it created. Now, you might be wondering if these events are so powerful, and if Einstein predicted these waves over a century ago, why did it take us so long to detect them? The answer is going to make you appreciate just how incredible modern science really is. The thing about gravitational waves is that they stretch and compress space itself as they pass through. But we're talking about incredibly tiny changes. When a gravitational wave from a black hole merger passes through Earth, it changes the length of a kilometer-long object by less than 1/10,000th the width of a proton. That's like trying to measure a change in the distance from Earth to the nearest star that's smaller than the width of a human hair. It's not just technically challenging, it seems physically impossible. But here's where human ingenuity comes in, and this is where our story gets really exciting. In the 1970s, physicists Rainer Weiss, Kip Thorne, and Barry Barish had an audacious idea. They would build a detector so sensitive that it could measure these impossible changes in spacetime. They called it LIG, or the Laser Interferometer Gravitational Wave Observatory. Think of LEGO like this. Imagine you have two perfectly straight roads, each 4 kilometers long, arranged in an L shape. Now imagine you can measure the length of these roads so precisely that you can detect when one becomes longer than the other by less than 1/10,000th the width of a proton. That's essentially what LEGO does, except instead of roads, it uses laser beams. And instead of measuring with rulers, it uses the interference patterns of light waves. When a gravitational wave passes through LEGO, it stretches space in one direction and compresses it in the perpendicular direction. This causes one laser beam's path to become slightly longer, while the other becomes slightly shorter. When the beams recombine, they create an interference pattern that changes in a very specific way, a way that tells us a gravitational wave has passed through Earth. Building LEGO required solving engineering problems that seemed impossible. The mirrors had to be isolated from every possible vibration. Earthquakes, trucks driving by, even people walking in the building. The vacuum chambers had to be perfect. The laser light had to be stabilized beyond anything previously achieved. And the data analysis required computational techniques that didn't exist when the project began. For decades, LEGO detected nothing. Well, not nothing. It detected trucks, earthquakes, people slamming doors, temperature fluctuations, and thousands of other sources of vibration and noise. But no gravitational waves. Critics called it the most expensive non-discovery in physics. Some wondered if gravitational waves even existed, or if they were just mathematical artifacts in Einstein's equations. But here's what nobody expected. Are you ready for this? On September 14th, 2015, at 4 hours 50 minutes and 45 seconds a.m. Central Daylight Time, LEGO detected something extraordinary. Both detectors, located 3,000 kilometers apart in Louisiana and Washington State, simultaneously recorded a signal that swept upward in frequency from 35 J to 350 Hz over a period of 0.2 seconds, exactly matching Einstein's predictions for two black holes spiraling into each other. The signal lasted just 1/5 of a second, but in that brief moment, it told an incredible story. Two black holes, each about 30 times more massive than our Sun, had been orbiting each other for perhaps millions of years, gradually spiraling inward as they lost energy to gravitational waves. In the final fraction of a second, they merged into a single black hole about 62 times the mass of the Sun. 3 solar masses worth of energy, that's 5.4 times 1047 joules, was converted into gravitational waves and blasted across the universe at the speed of light. But here's the most incredible part. This collision didn't happen recently. It happened 1.3 billion years ago, when Earth was populated only by single-celled organisms. The gravitational waves had been traveling through space for over 1 billion years, passing through galaxies, stars, planets, and finally arriving at Earth just in time for us to have built detectors capable of hearing them. When the scientists at LEGO first saw this signal, they couldn't believe it. They spent months verifying it, checking for errors, looking for any possible explanation other than a gravitational wave. Because if it was real, it meant they had just made one of the most important scientific discoveries in human history. They had detected ripples in space-time itself, confirmed Einstein's century-old prediction, and opened an entirely new window on the universe. The detection was so clear, so unmistakable, that scientists could convert it directly into sound waves. For the first time in human history, we didn't just see the universe, we heard it. The collision sounded exactly like what you might expect from two massive objects spiraling into each other. A low-frequency chirp that rises in pitch and amplitude, before abruptly cutting off. It's the sound of space-time itself being torn and twisted by forces beyond our imagination. But wait, there's something even more mind-blowing about this discovery. Remember how I said the gravitational waves are passing through you right now? Well, when that signal from 1.3 billion years ago reached Earth, it didn't just pass by our planet. It passed through everything: the oceans, the continents, every building, every person, including you. On September 14th, 2015, at 4 hours 50 minutes and 45 seconds a.m., your body was stretched and compressed by the merger of two black holes that collided on our planet. Was barely recognizable. Every atom in your body, every cell, every strand of DNA was gently squeezed and stretched by waves in space-time itself. You were personally touched by one of the most violent events in the universe, and you never even knew it. And here's what's really going to blow your mind. This wasn't a one-time event. Since that first detection, LIGO and its European counterpart, Virgo, have detected dozens more black hole mergers. We now know that black holes are merging somewhere in the observable universe about once every 5 minutes. Every 5 minutes, cosmic monsters are dancing their final dance, converting solar masses into gravitational wave energy. And those waves are washing over our planet like a cosmic ocean. We're only just learning to feel dot, but the story gets even more incredible when we start to understand what these detections are telling us about the universe. Are you ready to have your mind completely blown? Because what we've discovered about black hole mergers has rewritten our understanding of how the universe works at its most fundamental level. Before LIGO, we knew black holes existed, but we had never directly detected one. We inferred their existence from how they affected nearby stars and gas. Now, we can study them directly by listening to their mergers. And what we're learning is extraordinary. First, we've discovered that black holes are far more common than we ever imagined. The black holes we've detected merging are typically 20 to 100 times more massive than our sun. But until LIGO, we had never found any black holes in this mass range. We knew about smaller stellar mass black holes formed from individual star explosions, and we knew about supermassive black holes millions of times heavier than the sun at the centers of galaxies. But these intermediate mass black holes were a complete mystery. Where did they come from? How do two 30 solar mass black holes end up in a binary system in the first place? The answer is revealing secrets about how the very first stars in the universe lived and died. We think these black holes formed from some of the most massive stars that ever existed. Stars that burned so hot and fast that they exhausted their fuel and collapsed into black holes within just a few million years of the universe's birth. But here's where it gets really wild. Some of the black holes we're detecting are spinning at incredible rates, up to 95% of the theoretical maximum spin rate allowed by physics. Think about what that means. These are objects containing the mass of dozens of suns, compressed into regions smaller than Manhattan, spinning so fast that their surfaces are moving at nearly the speed of light. The amount of rotational energy stored in these spinning black holes is almost incomprehensible. And when two of these spinning black holes merge, something magical happens. The gravitational waves they produce carry away angular momentum, but they also carry away information about how the black holes were spinning before they merged. By analyzing the wave patterns, we can determine not just the masses of the original black holes, but their spin rates and even the angles of their spin axes. It's like cosmic CSI. We can reconstruct the entire collision, seen just from the waves it produced. Here's something that's going to completely change how you think about space and time. When these black holes merge, they don't just create waves in space-time. They create black holes with properties that seem to defy everything we thought we knew about physics. The final black holes are often spinning faster than either of the original ones, and they can be kicked through space at speeds of thousands of kilometers per second by the asymmetric emission of gravitational waves. Picture this: a black hole containing the mass of 60 suns, moving through space at 5,000 kilometers per second because it got kicked by its own gravitational wave emission. That's like a cosmic cannonball flying through the galaxy at speeds that would take it from Earth to the moon in less than a minute. These kicks can be so powerful that they launch black holes completely out of their host galaxies, sending them wandering through intergalactic space as cosmic nomads. But wait, there's more. And this is where things get really mind-bending. Some of the mergers we've detected show evidence of black holes that merged, then merged again with other black holes. We're seeing hierarchical mergers, black holes that are the products of previous mergers, merging with other black holes. It's like Russian nesting dolls, except each doll is a cosmic monster capable of warping space-time itself. This tells us something profound about the history of the universe. Black holes aren't just endpoints of stellar evolution. They're actively growing, merging, and evolving throughout cosmic history. Every black hole merger creates gravitational waves, but it also creates a new, more massive black hole that can merge again in the future. The universe is filled with the descendants of ancient black hole collisions, and those descendants are still colliding today. And here's something that's going to absolutely blow your mind. Remember how I said gravitational waves travel at the speed of light? Well, that means when we detect a black hole merger, we're not just hearing it. We're hearing it at exactly the moment the event would be visible if black holes could emit light. We're experiencing these cosmic catastrophes in real time, despite the fact that they happened millions or billions of years ago. But LIGO has given us more than just the ability to detect black hole mergers. It's given us a completely new sense with which to explore the universe. For all of human history, we've studied the cosmos using light, visible light, radio waves, X-rays, gamma rays. All of these are forms of electromagnetic radiation. But gravitational waves are something completely different. They're ripples in the fabric of space-time itself, and they carry information that electromagnetic waves simply cannot. Think of it like this: if you were deaf and could only see, you would miss the beautiful symphony of sounds that surrounds you every day. You could watch an orchestra perform, see the instruments moving and the musicians playing, but you would miss the music itself. That's what astronomy was like before LIGO. We could see the universe, but we couldn't hear it. Now we can hear the universe's most violent events as they happen. We can listen to black holes merging, neutron stars colliding, and possibly even the aftershocks of the Big Bang itself. We've entered the age of gravitational wave astronomy, and it's revealing aspects of reality that we never knew existed. But here's what really gets me excited about black hole mergers, and why I think they're the most important events in the universe. Every time two black holes merge, they do something that seems impossible. They convert mass directly into gravitational wave energy with an efficiency that makes nuclear reactions look pathetic. When hydrogen fuses into helium in the core of a star, about 0.7% of the mass is converted into energy. That's what powers every star in the sky, including our sun. When uranium undergoes nuclear fission, about 0.1% of the mass becomes energy. But when two black holes merge, up to 5% of their combined mass gets converted into gravitational wave energy. That's roughly 7 times more efficient than nuclear fusion. This means that black hole mergers are the most efficient energy conversion process we know of in the universe. In the final moments before two black holes merge, they're converting matter into energy more efficiently than any power plant, any star, any nuclear reaction we've ever observed. They're essentially perfect engines for converting matter into gravitational waves. And here's the kicker. That energy doesn't just disappear. Those gravitational waves carry energy across the universe. And when they interact with matter, they can actually do work. In principle, you could build a gravitational wave power plant. You could harvest the energy from black hole mergers happening billions of light years away. It sounds like science fiction, but the physics is real. Now, before we go any further into this cosmic rabbit hole, I need you to do something for me. Look around you. Look at the walls, the furniture, the air itself. Everything you're seeing is made of atoms that formed in the cores of stars that lived and died billions of years ago. You are literally made of stardust. That's not just a poetic metaphor. It's scientific fact. But here's what's even more incredible. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, these elements were forged in stellar furnaces and scattered across the galaxy when massive stars exploded as supernovas. But some of those stars didn't explode. Some of them collapsed directly into black holes. And those black holes have been merging and creating gravitational waves for billions of years. This means you're not just made of stardust, you're living in a universe that's been shaped by black hole mergers since the very beginning. The gravitational waves from countless black hole collisions have been washing over our galaxy for billions of years, gently influencing the formation of stars, planets, and ultimately, life itself. Every breath you take, every heartbeat, every thought you think is happening in a universe that's constantly rippling with the aftershocks of cosmic collisions that happened long before Earth even existed. You're not just an observer of these cosmic events, you're a product of them. But wait, there's something even more profound here. The ability for black holes to merge tells us something fundamental about the nature of space-time itself. You see, in Einstein's theory of general relativity, black holes aren't just objects in space. They're regions where space and time become so warped that our normal understanding of reality breaks down. When two black holes approach each other, their event horizons, the boundaries beyond which nothing can escape, begin to interact in ways that challenge our basic concepts of space and time. As they get closer, the geometry of space-time around them becomes increasingly complex, creating what physicists call a space-time foam, a region where the smooth fabric of space-time breaks down into quantum fluctuations on the smallest scales. In the final moments before merger, when the black holes are orbiting each other hundreds of times per second, the warping of space-time becomes so extreme that time itself starts to behave in bizarre ways. If you could somehow observe the merger up close and survive, which you couldn't, you would see time flowing at different rates in different locations around the merging black holes. Think about what this means. When two black holes merge, they're not just combining their masses. They're literally merging two separate regions of warped space-time into a single, larger region. They're performing surgery on the fabric of reality itself, cutting and restitching the fundamental structure of the universe. And here's what absolutely blows my mind about this. The final black hole that results from the merger has an event horizon that's larger than the combined areas of the original event horizons. This seems to violate basic mathematical logic. How can 1 + 1 equal more than 2? But it doesn't violate anything. It reveals something profound about how area and volume work in severely curved spacetime. This is described by something called the area theorem. discovered by Stephen Hawking in the 1970s. It states that the total area of black hole event horizons can never decrease. When two black holes merge, the area of the final event horizon is always greater than the sum of the original areas. It's like the universe has a built-in mechanism ensuring that black holes can only grow, never shrink. But here's where things get really weird. Hawking later discovered that black holes actually do evaporate by emitting what we now call Hawking radiation. This seems to contradict the area theorem. If black holes evaporate, their event horizons should shrink, right? The resolution of this paradox led to some of the deepest insights in modern physics about the relationship between gravity, quantum mechanics, and information theory. When we observe black hole mergers through gravitational waves, we're not just detecting cosmic collisions, we're probing the fundamental limits of physics itself. We're testing Einstein's theory of general relativity in the most extreme conditions possible, where gravity is so strong that it can bend light, slow time, and warp the very geometry of space. And you know what's incredible? So far, every black hole merger we've detected has matched Einstein's predictions exactly. Even though he developed his theory over a century ago, using only pencil, paper, and pure thought, it perfectly describes the behavior of merging black holes in conditions far more extreme than anything he could have imagined. But here's what's really going to blow your mind. The gravitational waves from black hole mergers are teaching us that space and time aren't just the stage where physics happens. They're dynamic, flexible, and responsive. When massive objects accelerate, they don't just move through space-time. They shake it, stretch it, and send ripples propagating outward at the speed of light. This means that space-time itself is a medium, like water or air, that can carry waves. But unlike water waves or sound waves, gravitational waves don't need a medium to travel through. They are disturbances in the medium of space-time itself. When a gravitational wave passes through you, it's not just affecting your body, it's temporarily changing the geometry of the space you occupy. For a brief moment, as each gravitational wave passes through Earth, the distance between atoms in your body changes ever so slightly. You become fractionally taller in one direction and fractionally thinner in another. Then the wave passes and you return to your normal shape. It's like the entire universe is gently massaging you with waves of curved space-time. Now, let me tell you something that's going to completely change how you think about your place in the cosmos. The detection of gravitational waves from black hole mergers has revealed that we're living in what scientists call a dynamic universe. A universe where this fundamental structure of space-time is constantly changing due to the motion of massive objects. Every massive object that accelerates creates gravitational waves. When you wave your hand, you create tiny ripples in space-time. When Earth orbits the Sun, it creates slightly larger ripples. But these waves are incredibly weak, so weak that we could never hope to detect them with any conceivable technology. The only sources strong enough for us to detect are the most extreme events in the universe: black hole mergers, neutron star collisions, and possibly the echo of the Big Bang itself. But here's the beautiful part. Even though we can only detect the strongest gravitational waves, the weak ones are there too. The universe is filled with an ocean of gravitational waves from every accelerating mass that has ever existed. Your movements, my movements, the movements of every living thing on Earth, we're all contributing to the gravitational wave background of the universe. In a very real sense, everything is connected through space-time. When you move, you create ripples that propagate outward at the speed of light, carrying information about your motion to the far reaches of the universe. Those ripples are unimaginably weak, but they're real. You are literally leaving your mark on the fabric of space-time itself. And here's something that's going to make you feel both insignificant and incredibly special at the same time. The gravitational waves we detect from black hole mergers have been traveling through space for millions or billions of years. They've passed through countless galaxies, star systems, and planets before reaching Earth. But in all that time, they've barely changed. They carry the same information about the original collision that they did when they first left their source. This means that when we detect a gravitational wave, we're not just hearing an echo of a cosmic event, we're experiencing that event directly, as if it were happening right now, right here. The waves that are passing through your body as you watch this video are the same waves that left two black holes as they merged billions of years ago. You are being touched by ancient cosmic violence, and that touch is as fresh and immediate, as if the collision happened yesterday. But here's what really gets me excited about the future of gravitational wave astronomy. What we've detected so far is just the beginning. We're like Galileo, pointing his first telescope at the moon, seeing craters and mountains where ancient observers saw only a smooth, perfect sphere. We've opened a new window on the universe, and we're only just starting to see what's out there. The current generation of gravitational wave detectors can hear the final moments of black hole mergers, the last few seconds or minutes before collision, when the gravitational waves are strong enough to detect. But future detectors will be sensitive enough to hear the entire spiral, following binary black holes for months or even years before they merge. Imagine being able to predict when and where a black hole merger will happen, then watching it unfold in real time through both gravitational waves and electromagnetic observations. We'll be able to study how black holes behave in the final moments before merger, test Einstein's theory in even more extreme conditions, and maybe even detect new physics beyond general relativity. But the most exciting possibility is that we might detect gravitational waves from events we haven't even imagined yet. The universe is full of massive accelerating objects, and some of them might create gravitational wave signatures unlike anything we've seen. We could discover new types of compact objects, observe the birth of black holes in real time, or even detect the gravitational wave signature of cosmic strings, hypothetical one-dimensional defects in space-time left over from the Big Bang. And here's something that's going to absolutely blow your mind. Some theorists think that the Big Bang itself might have created gravitational waves that are still propagating through the universe today. These primordial gravitational waves would carry information about the first moments after the universe began, when it was smaller than an atom and hotter than the core of any star. If we could detect these primordial gravitational waves, we would essentially be hearing the birth cry of the universe itself. We would have a direct connection to the moment when space and time began, when the fundamental forces of nature were first taking shape, when the seeds of every galaxy, star, and planet were first planted in the quantum foam of the early cosmos. Think about that for a moment. The same technology that allows us to hear black holes merging might someday let us hear the echo of creation itself. We might be able to listen to the universe when it was less than a second old, learning secrets about the origin of everything that exists. But let's bring this back to something more personal, because I want you to understand how black hole mergers are connected to your daily life in ways you've probably never considered. Every time two black holes merge, they convert several solar masses worth of matter into pure energy in the form of gravitational waves. That energy propagates through the universe at the speed of light, carrying information about the collision. Across billions of light years of space, when those waves finally reach Earth, they interact with every atom, every molecule, every cell in your body. For a brief moment, the gravitational wave changes the quantum mechanical wave functions of the electrons in your atoms, slightly altering the probability distributions that determine where those electrons might be found. It's an incredibly subtle effect, but it's real. This means that every gravitational wave that passes through you is literally changing you at the quantum level. You are being constantly modified by cosmic events that happened long before you were born. in galaxies you'll never see, involving objects so massive and so dense that they challenge our basic understanding of what matter can be. But here's what's even more incredible. Because gravitational waves travel at the speed of light, and because the universe is constantly expanding, the waves that reach us today left their sources when the universe was younger and smaller. We're not just detecting black hole mergers. We're detecting them as they were in the ancient past, when the cosmic conditions were very different from what they are today. Some of the mergers we've detected happened when the universe was less than half its current age. The black holes that merged to create these waves formed from stars that burned and died when our galaxy was still young, when the chemical composition of the cosmos was different, when the rate of star formation was much higher than it is now. By studying these ancient mergers, we're learning about the history of the universe itself. We're seeing how black holes have grown and evolved over cosmic time, how they've influenced the formation of galaxies and the distribution of matter in space. We're reading the biography of the universe, written in the language of gravitational waves. When those waves finally reach Earth, they interact with every atom, every molecule, every cell in your body. For a brief moment, the gravitational wave changes the quantum mechanical wave functions of the electrons in your atoms, slightly altering the probability distributions that determine where those electrons might be found. It's an incredibly subtle effect, but it's real. This means that every gravitational wave that passes through you is literally changing you at the quantum level. You are being constantly modified by cosmic events that happened long before you were born, in galaxies you'll never see, involving objects so massive and so dense that they challenge our basic understanding of what matter can be. But here's what's even more incredible. Because gravitational waves travel at the speed of light, and because the universe is constantly expanding, the waves that reach us today left their sources when the universe was younger and smaller. We're not just detecting black hole mergers. We're detecting them as they were in the ancient past, when the cosmic conditions were very different from what they are today. Some of the mergers we've detected happened when the universe was less than half its current age. The black holes that merged to create these waves formed from stars that burned and died when our galaxy was still young, when the chemical composition of the cosmos was different, when the rate of star formation was much higher than it is now. By studying these ancient mergers, we're learning about the history of the universe itself. We're seeing how black holes have grown and evolved over cosmic time, how they've influenced the formation of galaxies and the distribution of matter in space. We're reading the biography of the universe, written in the language of gravitational waves. But let me tell you something even more profound. The fact that we can detect gravitational waves at all is a testament to something remarkable about the cosmos. It's comprehensible. The same physical laws that govern the merging of black holes also govern the beating of your heart, the firing of neurons in your brain, the complex chemistry that allows life to exist. The gravitational waves from black hole mergers are more than just ripples in space-time. They're messages from the cosmos, telling us that we belong here, that we're part of something magnificent and vast and beautiful. Every wave that passes through you is a reminder that you are connected to the most powerful events in the universe. Now, let me blow your mind with something that's going to change how you think about time itself. When we detect gravitational waves from a black hole merger, we're not just hearing it happen, we're hearing it happen in slow motion. That's because of something called gravitational time dilation, one of the most mind-bending predictions of Einstein's relativity. As two black holes spiral toward each other, the immense gravity near the event horizons slows time down dramatically. If you could somehow observe the merger from close up, you would see the final moments stretched out over what feels like hours or even days. But from our perspective, billions of light years away, the entire final phase of the merger happens in less than a second. This means that when LIGO detects a gravitational wave chirp, It's hearing billions of years of slow orbital decay compressed into a fraction of a second of rapid inspiral and merger. We're listening to eons of cosmic evolution happening in fast forward, like watching the entire life cycle of a star compressed into a few minutes of time-lapse photography. But here's what's really incredible about this time dilation effect. It means that the gravitational waves carry information about how time itself behaves in the most extreme gravitational fields in the universe. By analyzing the frequency evolution of the waves, we can map out how time flows in the current spacetime. Around merging black holes, we're not just detecting cosmic collisions, we're studying the fundamental nature of time itself. And what we're learning is that time is not the constant, universal flow that we experience in our daily lives. Time is flexible, malleable, and intimately connected to the presence of matter and energy. Near a black hole, time crawls. In empty space, time flies. And during a black hole merger, time does things that would seem impossible to anyone who hasn't studied Einstein's equations. Think of it like this. Imagine you could slow down or speed up different parts of a symphony while keeping other parts at normal tempo. That's essentially what happens to time during a black hole merger. Different regions of spacetime are experiencing time at different rates, and the gravitational waves carry information about these temporal distortions across the universe. But wait, there's something even more mind-bending about black hole mergers that's going to completely change how you think about information and reality. You see, when two black holes merge, they create what physicists call an information paradox. Here's the problem. According to quantum mechanics, information cannot be destroyed. But according to general relativity, anything that falls into a black hole can never come back out. So what happens to the information carried by the matter that originally formed the black holes? When two black holes merge, are we destroying information about the particles that fell into them millions of years ago? Or is that information somehow preserved in the gravitational waves that the merger produces? This is one of the deepest, unsolved problems in modern physics, and it touches on the most fundamental questions about the nature of reality. If information can be destroyed in black hole mergers, then the universe is not deterministic. The past cannot be reconstructed from the present, and the fundamental laws of physics are not reversible. But if information is preserved, then the gravitational waves from black hole mergers must somehow encode the quantum, mechanical information of every particle that ever fell into either black hole. The waves would carry not just information about the masses and spins of the merging objects, but detailed quantum information about their internal structure. Some theorists think that this information is encoded in incredibly subtle correlations in the gravitational wave pattern, correlations so complex that we would need quantum computers more powerful than anything we can currently imagine to decode them. Others think that the information escapes through Hawking radiation, the quantum mechanical process by which black holes slowly evaporate. But here's what's really exciting about this problem. Every black hole merger we detect is a natural experiment in quantum gravity, the hypothetical theory that would unify Einstein's general relativity with quantum mechanics. By studying these mergers in ever greater detail, we might be able to resolve the information paradox and discover new physics beyond our current understanding. Now, let me tell you about something that's happening right now that's going to absolutely blow your mind. As I speak these words, there are black hole mergers happening throughout the universe. Not just one or two, but hundreds, maybe thousands of them occurring every day. Each one is converting multiple solar masses into gravitational wave energy and broadcasting that energy across the cosmos at the speed of light. Most of these mergers are too distant or too weak for us to detect with current technology, but they're happening nonetheless, creating a background chorus of gravitational waves that permeates all of space. It's like a cosmic ocean of waves, with storm systems of black hole mergers creating large waves, and the steady background of distant, undetectable mergers creating a gentle swell that never stops. You are floating in this ocean right now. As you listen to these words, gravitational waves from dozens of black hole mergers are passing through your body. Some of them left their sources yesterday, some 1,000,000 years ago, some 1,000,000,000 years ago. They're all here, all now, all gently stretching and compressing the space around you with the echoes of cosmic violence. But here's what's even more incredible. The gravitational wave background isn't just random noise. It carries information about the history of black hole formation and evolution throughout cosmic time. By mapping this background in detail, future gravitational wave observatories will be able to reconstruct the rate of black hole mergers as a function of cosmic time. We'll learn when the first black holes formed, how rapidly they grew through mergers, and how their merger rate has changed as the universe has aged. We'll see the fingerprints of cosmic evolution written in the gravitational wave sky, like reading the rings of a cosmic tree that's been growing for 13.8 billion years. And here's something that's going to make you feel like you're part of the biggest story ever told. The detection of black hole mergers has revealed that we're living during a special time in cosmic history, the age of gravitational wave astronomy. For most of the universe's history, there was no life complex enough to build gravitational wave detectors. In the distant future, the expansion of space will carry the sources of gravitational waves so far away that they'll become undetectable. But right now, in this brief window of cosmic time, the universe has evolved beings, us, capable of hearing its most violent events. We are the universe's way of listening to itself, of understanding its own violent beauty, of appreciating the cosmic symphony that has been playing since the first black holes formed in the early cosmos. Think about the incredible chain of events that had to happen for this moment to be possible. Stars had to form and die to create the heavy elements needed for planets and life. Galaxies had to merge and evolve to create the right conditions for stable star formation. Life had to evolve from simple chemicals to complex organisms capable of thought and technology. And all of this had to happen during the brief window when gravitational wave sources are detectable from Earth. The fact that you exist, that you can understand these concepts, that you can appreciate the beauty of black holes merging in distant space. This is perhaps the most improbable and wonderful thing in the universe. You are a way for the cosmos to know itself, to understand its own deepest mysteries, to marvel at its own magnificent violence and beauty. But let's talk about what black hole mergers mean for the future. Because the ability of black holes to merge isn't just an interesting astronomical phenomenon, it's a fundamental process that's shaping the evolution of the universe itself. Every time two black holes merge, they create a single black hole that's more massive than either of the original ones. This means that black holes are steadily growing throughout cosmic time, becoming more and more dominant gravitational influences in their local regions of space. In the far future, black hole mergers will be one of the primary drivers of cosmic evolution. Computer simulations suggest that in the distant future, we're talking trillions of years from now, most of the matter in the universe will eventually find its way into black holes through this process of steady growth and merger. Stars will burn out, planets will be absorbed, and even entire galaxies will eventually spiral into the supermassive black holes at their centers. But here's the beautiful part. Even when the last star has burned out and the universe is gone, cold and dark, black holes will still be merging, still creating gravitational waves, still rippling the fabric of space-time with the echoes of their cosmic dances. The universe will continue to sing, even in the darkness. And eventually, even the black holes themselves will evaporate through Hawking radiation, returning their mass energy to the universe in the form of elementary particles and photons. The universe will end not with a bang, but with a whisper, The final gravitational wave chirp from the last two black holes in existence, merging together in the cold emptiness of a universe that has almost forgotten how to create anything new. But that's trillions upon trillions of years in the future. Right now, we're living in the universe's prime time, the age of stars and galaxies and black hole mergers, and, most importantly, the age of minds capable of understanding it all. Now, before we conclude this cosmic journey, I want to share with you one final mind-blowing revelation about black hole mergers. Are you ready for this? Because what I'm about to tell you might fundamentally change how you see your place in the universe. Remember how I said that gravitational waves stretch and compress space as they pass through? Well, that stretching and compressing doesn't just affect inanimate objects. It affects biological systems too. Every gravitational wave that passes through your body is temporarily changing the spacing between your atoms, the distances between molecules in your cells, even the quantum mechanical wave functions that determine the behavior of particles in your brain. Now, these changes are incredibly tiny, far too small to have any noticeable effect on your health or consciousness. But they're real. This means that your thoughts, your memories, your very sense of self is being constantly, subtly influenced by gravitational waves from black hole mergers that happened millions or billions of years ago. You are not just observing the universe, you are participating in it at the most fundamental level. Every thought you think is shaped in some infinitesimal way by the merger of cosmic titans that collided before your planet even existed. You are a quantum mechanical system embedded in a dynamic space-time that's constantly rippling with the aftershocks of the most violent events in cosmic history. But here's what I find most beautiful about this connection. The same physical processes that allow black holes to merge, the curvature of space-time, the propagation of gravitational waves, the conversion of mass into energy, also allow atoms to bind into molecules, molecules to organize into cells, and cells to organize into brains, capable of consciousness and wonder. You are not separate from the cosmic processes that create and destroy black holes. You are a local manifestation of those same processes, a temporary arrangement of matter and energy that has become complex enough to contemplate its own existence and to understand its connection to the deepest structures of reality. When two black holes merge and send gravitational waves rippling across the universe, they're not just demonstrating the power of gravity or the validity of Einstein's equations. They're participating in the same fundamental dance of matter, energy, space, and time that gave rise to stars, planets, life, and consciousness. You are made of atoms forged in stellar cores, living on a planet orbiting a star in a galaxy shaped by billions of years of black hole mergers, in a universe where the very fabric of space-time carries the memory of every cosmic collision that has ever occurred. You are not just in the universe, you are the universe, temporarily organized into a form capable of understanding and appreciating its own magnificent complexity. Every time you learn something new about black holes, every time you feel wonder at the vastness of space or the beauty of physical law, every time you connect with another person over shared amazement at the cosmos, you are fulfilling the universe's deepest purpose. You are the way the universe comes to know and appreciate itself. The gravitational waves from merging black holes are love letters from the cosmos, written in the language of curved space-time and addressed to any intelligence capable of reading them. They tell the story of cosmic evolution, of the birth and death of the most massive objects in nature, of the fundamental forces that shape reality at every scale. And the most incredible part is that you can read these letters. You, a collection of carbon atoms organized into consciousness, can understand the merger of black holes containing the mass of dozens of suns. You can appreciate the beauty of Einstein's equations, feel wonder at the detection of gravitational waves, and comprehend your connection to events happening billions of light years away. This is perhaps the most miraculous thing in the universe. Not the black holes themselves, not the gravitational waves they produce, not even the incredible technology we've built to detect them. The most miraculous thing is that you exist to wonder about it all, to ask questions, to seek understanding, and to feel connected to the cosmic processes that created everything you see and everything you are. So the next time you look up at the night sky, remember that you're not just seeing distant stars and galaxies. You're seeing the products of billions of years of cosmic evolution, shaped by countless black hole mergers, permeated by gravitational waves that carry the memory of every cosmic collision that has ever occurred. And remember that you are not just an observer of this cosmic drama. You are a participant, a local concentration of the same matter and energy that forms black holes, shaped by the same physical laws that govern their mergers, connected through space-time to every other object in the universe by the gravitational waves that are constantly rippling through the fabric of reality. You are the universe awakening to its own beauty, its own complexity, its own magnificent capacity for creating arrangements of matter complex enough to contemplate their own existence. You are stardust that has learned to wonder about stars, cosmic dust that has organized itself into consciousness and curiosity, and the capacity for joy. That the black holes merging in distant galaxies are your cosmic relatives, fellow travelers in the great journey of matter and energy through space and time. The gravitational waves they create are connecting you to them, carrying information across billions of light years of space, reminding you that you belong to something vast and ancient and beautiful beyond imagination. And in the end, that's the most important thing about black hole mergers. They're not just cosmic catastrophes or interesting astronomical phenomena or tests of Einstein's equations, though they are all of these things. They're reminders of your place in the cosmic story, not as a tiny, insignificant speck in an unpairing universe, but as a conscious, curious, capable participant in the greatest adventure that has ever been, the universe coming to understand itself. You are here. Now, in this moment of cosmic history, when black holes are merging and gravitational waves are rippling through space, and minds like yours exist to detect and understand and wonder at it all. You are part of the answer to the universe's deepest question. What is it like to exist? Every time two black holes merge, they're not just creating gravitational waves, they're creating opportunities for wonder, for discovery, for the kind of deep cosmic connection that reminds us why we're here and what it means to be conscious beings in an extraordinary universe. So yes, black holes can merge into one. But more than that, they do merge into one, constantly, throughout the cosmos, creating the most powerful events in the universe and connecting all of us to the deepest mysteries of existence through the invisible ocean of gravitational waves that surrounds us, permeates us, and gently reminds us that we are all part of something magnificent, beyond our wildest dreams. Thank you for joining me on this journey through the cosmos. If this video has changed how you see your place in the universe, hit that subscribe button and let me know in the comments. What's the most mind-blowing thing you learned today? And remember, every time you share this knowledge with someone else, you're helping the universe understand itself a little bit better. Until next time, keep looking up, keep wondering, and keep remembering that you are made of stars, shaped by cosmic forces, and connected to everything that has ever been or ever will be. The universe is vast, ancient, and beautiful beyond imagination. And you are its way of knowing that it's vast, ancient, and beautiful beyond imagination. Never forget how extraordinary that makes you. But wait, I'm not done blowing your mind yet. Because there's something about black hole mergers that's so incredible, so fundamentally world-changing, that it's going to rewrite everything you thought you knew about the future of humanity itself. What if I told you that black hole mergers might be the key to humanity's survival as a species? That the same cosmic catastrophes we've been talking about could become the ultimate energy source for an advanced civilization? Here's something that's going to sound like science fiction, but is actually serious scientific speculation. Remember how I mentioned that black hole mergers are the most efficient energy conversion process in the universe, converting up to 5% of mass directly into energy? Well, some physicists have proposed that a sufficiently advanced civilization could actually harvest this energy. They could position massive structures around merging black holes and collect the gravitational wave energy as it propagates outward. Think about the implications. A single black hole merger releases more energy than all the stars in the observable universe combined. If you could capture even a tiny fraction of that energy, you could power an entire galactic civilization for millions of years. You could run planet-sized computers, build continent-sized cities, even terraform entire star systems. But here's where it gets really wild. Some theorists suggest that advanced civilizations might not just harvest black hole mergers, they might actually create them. By carefully manipulating the orbits of black holes using advanced technology, a Type 3 civilization on the Kardashev scale could engineer black hole collisions, timing them and positioning them to maximize energy extraction. Imagine this. Civilizations so advanced that they treat black holes like we treat hydroelectric dams. They capture pairs of black holes, shepherd them into precisely calculated orbits, and then harvest the gravitational wave energy when they merge. It's like cosmic engineering on a scale that makes our largest. Construction projects look like SANDCASTLES. And here's something that's going to absolutely blow your mind. If such civilizations exist, we might actually be able to detect them. Artificial black hole mergers would have different characteristics than natural ones: more precise timing, unusual orbital configurations, patterns that suggest intelligent design rather than random cosmic evolution. Every time LIGO detects a black hole merger, scientists analyze the data not just for astrophysical information, but for any signs of artificial manipulation. We're essentially conducting SETI, the search for extraterrestrial intelligence, through gravitational waves. We're listening for the signatures of cosmic engineers who might be using black holes as tools. But let me tell you about something even more mind-bending. Some physicists have proposed that black hole mergers might be connected to the creation of new universes. This comes from a wild idea in theoretical physics called the many worlds interpretation of quantum mechanics, combined with speculations about what happens inside black holes. Here's the theory. When matter falls into a black hole, it might not be destroyed. Instead, it might trigger the formation of a new universe with its own space and time, completely disconnected from our own. If this is true, then every black hole merger isn't just combining two existing black holes. It might be creating the conditions for entirely new universes to be born. Picture this. Every time two black holes merge, the extreme conditions at the moment of collision might cause space-time to bubble off into a separate reality. The gravitational waves we detect would be the birth cries, not just of a new black hole, but of entire new cosmos with their own physics, their own matter, their own potential for life and consciousness. This means that the black hole merger you learned about earlier, the one that happened 1.3 billion years ago and created the first gravitational waves we ever detected, might have also created a universe where beings like you are just now evolving, just now developing technology, just now wondering if they're alone in the cosmos. Think about the implications. Every gravitational wave that passes through your body might be carrying information not just about cosmic collisions, but about the births of entire universes. You're being touched by the aftershocks of creation itself, over and over again, as new realities come into existence through the merging of black holes. But here's what really gets me excited about the future of black hole merger research. We're on the verge of a revolution in how we study these events. The next generation of gravitational wave detectors will be so sensitive that they'll detect not just the final moments of black hole mergers, but the entire process from beginning to end. The Einstein telescope, currently being planned in Europe, will be able to detect black hole mergers from when they first form as binary systems, potentially billions of years before they actually collide. We'll be able to watch the entire cosmic drama unfold, a gradual spiral inward, the exchange of matter and angular momentum, the final catastrophic merger, and even the aftermath as the merged black hole settles into its final state. Even more exciting is the possibility of space-based gravitational wave detectors, like LISA, the Laser Interferometer Space Antenna, because these detectors won't be limited by Earth's seismic noise and gravitational disturbances. They'll be sensitive to gravitational waves at much lower frequencies. This means they'll detect different types of sources: massive black holes merging at the centers of galaxies, white dwarf stars spiraling into black holes, and maybe even the gravitational wave background from the Big Bang itself. Imagine being able to map every black hole merger in the observable universe, tracking how these cosmic monsters have grown and evolved since the first stars formed. We'll create a four-dimensional map of black hole evolution, showing not just where they are in space, but how they've changed over cosmic time. And here's something that's going to make you feel like you're living in the most exciting time in human history. We're not just passive observers of these cosmic events, we're actively participating in their discovery. Every time you share a video about black holes, every time you talk to someone about gravitational waves, every time you feel wonder at the cosmos, you're contributing to humanity's collective understanding of the universe. The scientists who built LIGO and detected the first gravitational waves, they're humans just like you, driven by the same curiosity and wonder that you're feeling right now. They spent decades of their lives, entire careers, working on a project that seemed impossible to most people. They faced ridicule, funding cuts, and technical challenges that would have stopped lesser minds. But they persevered because they understood something profound. The universe wants to be understood. It's filled with clues and signals and messages written in the language of physics, waiting for minds curious enough to decode them. And when we do decode them, when we hear the song of merging black holes for the first time, when we feel the ripples of distant cosmic catastrophes, we're not just advancing science. We're fulfilling our deepest purpose as conscious beings. Here's what I want you to understand about your place in this cosmic story. Right now, as you're processing this information, your brain is performing computations that are, in their own way, as remarkable as the collision of two black holes. You're taking patterns of light and sound, the photons hitting your retina, the air pressure waves reaching your eardrums, and converting them into understanding, into wonder, into a deep appreciation for your connection to the cosmos. Same physical laws that govern the merger of black holes also govern the firing of neurons in your brain. The same quantum mechanics that describes the behavior of particles falling into a vent. Horizons also describes the chemical reactions that allow your brain cells to communicate with each other. You are a biological gravitational wave detector, sensitive not to ripples in space-time, but to patterns in information that reveal the deep structure of reality. And just as gravitational waves carry information about cosmic events across billions of light years of space, your thoughts and ideas can carry information about these discoveries across the network of human consciousness. Every time you share what you've learned, every time you inspire someone else to look up at the night sky with wonder, you're propagating waves of understanding through the collective intelligence of our species. But let me tell you about one more mind-blowing aspect of black hole mergers that's going to change how you think about the nature of reality itself. It has to do with something called black hole complementarity, one of the strangest and most counterintuitive ideas in modern physics. Here's the paradox. According to general relativity, if you fall into a black hole, you pass through the event horizon and continue falling toward the singularity at the center. From your perspective, nothing special happens at the event horizon. It's not a physical barrier, just a mathematical boundary in space-time. But according to quantum mechanics, information cannot be destroyed. This means that all the information about your quantum state must somehow remain accessible to observers outside the black hole. Some physicists think this information is encoded in the Hawking radiation that the black hole emits as it evaporates. The resolution to this paradox leads to an incredible conclusion. Reality itself might be fundamentally complementary. The same event, you falling into a black hole, can have multiple, apparently contradictory descriptions that are all equally valid depending on your perspective. From the perspective of someone falling in, you pass through the event horizon and are eventually destroyed at the singularity. From the perspective of someone watching from outside, you never actually cross the event horizon. Instead, you appear to slow down and freeze at the boundary, your information encoded in the quantum fluctuations of the event horizon itself. Both descriptions are true, both are complete. Both represent valid ways of understanding what happens when matter encounters a black hole. Reality is not singular, it's complementary, allowing for multiple, seemingly contradictory truths to coexist. When two black holes merge, this complementarity becomes even more complex. The merger can be described from the perspective of observers at different locations, each seeing a different but equally valid version of events. The gravitational waves themselves might carry information that allows these different descriptions to be reconciled, encoding the full quantum mechanical truth of the merger in their subtle patterns. This suggests something profound about the nature of consciousness and observation. Your ability to understand and appreciate black hole mergers isn't just a passive reception of information. It's an active participation in the creation of reality itself. The universe doesn't have a single objective truth waiting to be discovered. Instead, it has multiple complementary truths that come into existence through the act of observation and understanding. You are not just learning about black holes, you are participating in the cosmic process by which the universe comes to understand itself. Your consciousness is not separate from the physical processes that create and destroy black holes. It's an integral part of the mechanism by which reality takes on definite form and meaning. And here's the most beautiful part of all this. The fact that black holes can merge, the fact that we can detect their gravitational waves, the fact that you can understand and appreciate these cosmic events, all of this is only possible because the universe has exactly the right properties to allow for the emergence of complexity, consciousness, and understanding. If the fundamental constants of physics were even slightly different, if gravity were a little stronger or weaker, if the nuclear forces had different strengths, if the quantum mechanical properties of matter were altered in subtle ways, black holes might not form, or they might not be able to merge, or their mergers might not produce detectable gravitational waves. But in our universe, everything is perfectly balanced to allow not just for the existence of black holes and their mergers, but for the evolution of minds capable of discovering and understanding these phenomena. The cosmos is not just stranger than we imagine, it's stranger than we can imagine. And yet, it's also comprehensible to minds like yours that have emerged from the same physical processes that create black holes. This is perhaps the deepest mystery of all. Why is the universe comprehensible? Why can patterns of matter and energy organized into brains like yours understand the collision of objects so massive and so distant that they defy everyday intuition? Why does mathematics, invented by human minds to solve practical problems, turn out to describe with perfect accuracy the merger of black holes billions of light years away? The answer, I think, is that you are not separate from the universe you're trying to understand. You are the universe, temporarily organized into a form capable of self-reflection and wonder. The same physical laws that govern black hole mergers also govern the organization of matter into living systems, the evolution of complexity, and the emergence of consciousness. When you understand something about black holes, you're not imposing human concepts on an alien reality. You're discovering the deep structure of the reality of which you are a part. You're uncovering the mathematical harmony that underlies both the collision of cosmic titans and the firing of neurons in your brain dot. So as we reach the end of this cosmic journey together, I want you to remember this. Every gravitational wave that has ever passed through your body, every black hole merger that has ever rippled through space-time, every moment of wonder you felt while learning about the cosmos, these are all part of a single magnificent story. The story of a universe that has organized itself into forms complex enough to understand and appreciate its own beauty. You are living stardust that has learned to contemplate stars. You are quantum mechanics made conscious, relativity given awareness, the cosmic dance of matter and energy temporarily, arranged into a pattern that can witness and wonder at the cosmic dance itself. The next time you feel small or insignificant, remember that you carry within your mind the ability to comprehend the merger of black holes. You can hold in your thoughts events so energetic that they reshape the fabric of space-time itself. You can feel connection across billions of light years of space and billions of years of time to cosmic catastrophes that happened before your planet even existed. And remember that your capacity for wonder, your ability to be amazed by these discoveries, your deep emotional connection to the cosmos, these are not accidents or afterthoughts. They are fundamental features of a universe that has evolved the capacity to know and appreciate itself through minds like yours. Keep asking questions. Keep feeling wonder. Keep looking up at the night sky and remembering that you're not just under the stars, you're made of them, connected to them, part of the same cosmic story that includes the most powerful and beautiful events in the universe. And if you've enjoyed this journey through the cosmos, if it's changed how you see your place in the universe, make sure to subscribe for more mind-blowing explorations of reality. Share this video with someone who needs to remember how extraordinary they are. And let me know in the comments, what aspect of black hole mergers amazed you the most? Because every time you share wonder, every time you help someone else feel connected to the cosmos, you're participating in the universe's greatest achievement, the evolution of consciousness, capable of appreciating the magnificent, violent, beautiful cosmic dance of which we are all a part. Until next time, remember, you are made of stars, you are connected to black holes, and you are the universe's way of knowing how extraordinary it is to exist at all. Keep wondering, keep learning, and keep remembering that in a cosmos full of black hole mergers and gravitational waves and cosmic violence on scales beyond imagination, the most remarkable thing of all is that you exist to witness and understand. The universe is not just vast and ancient and beautiful. It's vast and ancient and beautiful, and aware of its own vastness and ancientness and beauty through minds like yours. And that, perhaps, is the most mind-blowing thing of all.